I'm Denny Newman-Griffis, and I'm delighted to be presenting our TextEssence system for analysis of semantic shifts between corpora. Now, we know that language changes in lots of different ways, and that can be change over time, like in the corpus of Historical American English, or COHA, or differences between settings, like medical language in hospitals versus community care. So TextEssence is a toolkit and a workflow that lets you analyze what that change looks like using word and concept embeddings. In this talk, I'll be using a case study of how research literature related to COVID-19 has evolved over time to show how TextEssence works in practice. I'll start by walking through an overview of how the TextEssence system works. So the first step is deciding what it is that you want to compare. Now that can be different versions of the same corpus over time to look at temporal differences, or corpora from different communities to look at social differences. In our case study, we took a temporal approach and used the COVID-19 dataset of COVID-related scientific literature and looked at how it was changing from month to month. So here, our unit of analysis, or each corpus, is 1 month's worth of COVID-19 papers. The second step, then, is to define how it is that you're going to measure that change between the corpora. So you can measure it in terms of shifts in word usage patterns, shifts in how domain concepts are described, or other kinds of measures. Once you've chosen what to learn embeddings for and the data to use, the next step is to learn the embeddings, train the embeddings from each corpus. So TextEssence can work with any kind of embedding, with word embeddings, with concept embeddings, actually even with graph embeddings. And beyond the type, TextEssence is also agnostic to the embedding method that's used. So for our case study, we used concept embeddings derived from the SNOMED-CT clinical vocabulary. So these are medically relevant terms, and trained from monthly copies, monthly snapshots of COVID-19 using JET, a distantly supervised entity representation learning method. So after running each corpus then through the chosen embedding method, we can compare the embeddings for any given word or concept, like here PPE or hydroxychloroquine, by looking at its nearest neighbors from each corpus. Now, we know from past work that nearest neighbors may change if you train your embeddings again. So you see here examples of different neighbors for the concept PPE from different runs. And this is with the same corpus, with the same algorithm, and we get pretty different nearest neighbors, which means that if we're using a nearest neighbor-based analysis approach, looking at this embedding of PPE over time, or at least within this particular monthly version, may not really tell us very much. So we developed a stability measure based on nearest neighborhood overlap across multiple runs. So with these two replicates of the PPE embedding, we see one neighbor in common. Whereas with cough, all three of these neighbors are shared. So cough we would consider to be stable, and PPE is probably too unstable to be informative. In our case study, we calculated overlap between 10 embedding replicates from each corpus. So that's pairwise overlap between every pair within those 10 replicates. So once we've gone through this process and identified those stable concepts, we can then calculate overall nearest neighbors, using only the concepts that we have stable embeddings for. So in this case, we know that PPE is not stable, so we'll ignore it in the neighbor calculation. And the final nearest neighbors are then calculated based on averaged pairwise distance across all the embedding replicates, which helps us further control for noise in the embedding process. So the overall workflow, going from corpus to stable nearest neighbors, looks like this. We start from our single corpus by training multiple embedding replicates. We'll then calculate the nearest neighbors in each of those replicates, see which embeddings have stable neighbors across the replicates, and calculate our final nearest neighbors using the stable embeddings only. So running this process on each corpus, we then get our concepts and our neighbors for comparison. Those concepts and neighbors then get passed into the web interface for TextEssence, which lets you interactively explore the embeddings in 3 different ways. You can browse the embedding space by mousing over and clicking individual embeddings. You see the nearest neighbors, and you can also mouse over a different corpus to see how they change. You can also then see how the overall embedding space changes between corpora as we calculate an alignment between the embeddings and illustrate how they reorganize. For a specific embedding, you can inspect the strings that it's linked to and its stability across the different corpora. And you can then look at its nearest neighbors from each corpus, seeing which ones are shared, and when the embedding is low confidence or unstable. Finally, you can choose two embeddings to compare and see their similarity across the different corpora, as well as the nearest neighbors from each of those for each of those embeddings from each of the corpora. So our case study on Chord 19 has shown that TextEssence is able to pick up on significant shifts that have occurred in the COVID research literature, and I'll highlight a few of those now. With anosmia, just the loss of smell, we see a clear shift from this being a general gustatory concept in the early days, in June and even into September, to something correlated with other known symptoms of COVID. And this mirrors the shift in understanding of anosmia in summer of 2020. With N95 respirators, we see a shift over time from highly professionalized protective equipment towards more general concepts related to personal protection, including materials for face masks. And with the corticosteroid dexamethasone, which has been used to treat severe COVID symptoms, we don't see the concept itself change significantly, but we do see this other corticosteroid ruxolitinib appear. And this reflects its emerging use in treating COVID symptoms. And looking then a little bit more detailed at the similarity over time between dexamethasone and ruxolitinib, we see this growing similarity that really reflects ruxolitinib's increasing role in the scientific literature. So to recap, TextEssence is a reusable system for analyzing semantic differences between corpora. We used it to analyze COVID-related scientific literature. It can also be used for other long-term change tracking, or even for tracking sudden shifts around a big event, like the 2020 US election, and also for more comparative analysis of corpora from different communities. We built TextEssence as a tool to help leverage embedding technologies as a tool for corpus linguistics. And we're really excited to keep growing this area, and there are a wide range of questions to study with this tool. For example, most of the work that we've done so far has been looking at known shifts that we expected TextEssence to capture. But corpus embeddings could also be used to automatically mine where semantics have shifted the most, or even detect what shifts may be coming. At the same time, it's intriguing to ask how fine-grained can you get, and how much text do you need in order to work with a corpus? Because of course, as you get more fine-grained in your analysis, the harder then it becomes to get sufficient text to really train a high-quality embedding. And then we're also really interested in digging into what you can get with for qualitative analysis purposes out of different embedding methods. And this is something that TextEssence gives us a tool to do, which is to really say, we can take the same corpus and take the same kinds of concepts or the same words, learn representations using different embedding methods, and then use TextEssence to see, what do you get in terms of the qualitative analysis. So you can find TextEssence with its code, its data, and a live demonstration at this website, and we look forward to hearing your thoughts on it. Thank you very much.